Okay, good morning. Welcome to
SuperMath number 78.
SuperMath78. So we're revisiting the problem we did this morning after talking about it a little bit and seeing if we've learned a little bit of some problem-solving lessons. An angle bisector passes through the circumcenter of a triangle. Prove that the triangle is isosceles. Okay?
All right.
Do you understand the problem?
Yep.
All right. Let's see how we can approach this problem. All right. Go ahead.
So, I'll just draw any old triangle. And so, the angle bisector, I'll just use this top one.
Okay.
It's going to pass through the circumcenter. And the circumcenter is the point where the perpendicular bisectors meet. So, I'll draw the perpendicular bisectors. So that one. You only really need two, just to show it.
Okay.
So, and they're perpendicular bisectors. So.
All right. So why is labeling those sides like that important?
Well, it's just that's what perpendicular bisectors do. They come down at the midpoint and chop it into two equally spaced line segments.
Right, but that's true. Whether you label them or not, that's true. So why is it important to label that?
Well, it could come in handy.
It could come in handy. And as you get sort of involved in a problem, sometimes you sort of, forget what one of the conditions or something like that, or forget what you're looking at. So it's important to label things, even if it seems kind of unnecessary, because that's what perpendicular bisectors do, but it's good to label. Okay.
So
we know the angle bisector passes through this big dot, right?
Big dot theory.
Big dot theory.
So now, I'll look at these triangles. We have these two right triangles. And we know that these are of equal length because they come off the angle bisector, and there's two perpendiculars from the angle bisector leading to two different sides are equal.
Okay, great. That's a great observation.
So now we have side angle side congruency. Well, actually,
wait a minute.
it's side. Well, side angle angle. Because we know these are the same, and we have this angle and this angle.
Okay, so we have angle, side.
Congruency.
Angle, side congruency, which is actually the same as angle, side, angle. Because if you know this angle and you know this angle in a triangle, what do you know?
You know the third angle.
You know the third angle. Okay, so we know that angle has to be equal to that angle. So we really have angle, side, angle, but angle, side says that too. Okay.
So more importantly, this side is equal to this side.
That side is equal to that side. Yeah.
And this is the midpoint
Since it's
of
the
this
midpoint,
side. Those are equal too.
Those are equal. So suddenly, if we have an if we have the situation where the angle bisector passes through the center of the circumscribed circle,
it's isosceles.
it has to be isosceles, that triangle. In fact, even more has to be true. Because in an isosceles triangle, the perpendicular bisector is going to go through the midpoint, up through the vertex.
It's also the angle bisector.
So in an isosceles triangle, you'll find that the perpendicular bisector is also the angle bisector to the side that's not part of the isosceles triangle. Sorry, I'm not saying that well. But this is a good challenge problem, and we saw before why it's a good challenge problem. You have to keep track of a lot of things. And a good lesson from losing track of those things before is just make sure you label what you know as you go along in these solutions, because you never know when it's going to come in handy, right?
Yeah.
All right, good job.